Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
So in the previous number of video tutorials, specifically now that we're working with the Terra Snow data product, we've been exploring terrain and characteristics of terrain, i.e. terrain analysis using a digital elevation model, specifically the elevation band. And from that we use Earth Engine functions, built-in functions to generate a slope, a hillside, an aspect ratio, etc., etc. And then we played around with the visualization parameters. We overlay these images and trying to highlight specific features, i.e. locations that have significant or some level of snow cover. Okay, so we made a connection between snow cover and terrain, and we confirmed, or we worked in QGIS just to sort of duplicate and get a better understanding of what we're doing in Earth Engine. So as I said previously, what we also want to do is look at temperatures, climate. We've looked at terrain, we've isolated terrain characteristics for snow cover. Now let's play around with temperatures and see whether we can get any wiser when it comes to snow cover and climatic characteristics. Okay, so we're building on and we're building on and we're building on, adding more and more data products to our basic snow cover data product. And so we're learning more and we're learning more. And again, this is with the focus is to learn from space, learn characteristics or features on Earth from space. And that's the remote sensing, and that's the essence of remote sensing. Okay, so we want to work with climate and specifically temperatures. Okay, so what we're going to have to do is let's go back to our script. Okay, remember to save the script, etc. Just in the meantime, what I've done is I played around a little bit with the snow cover, and I generated the image that looks something like this. I was not too happy with the visualization of my previous images, snow cover images, so I worked on this. And so I've created a specific visualization parameter for snow cover, which is basically this color scheme. Okay, so I added this color scheme: green, no area; pink, generally no area but light snow, and then you get to the red, which is moderate, and then the yellow and the white, which is very high levels of snow cover. So if I zoom in, you can see this ridge here. Okay, this ridge here, and I think we've referred to it a couple of times. So that's that ridge, and again we looked at the terrain in terms of the slope of these places or locations of snow cover and the aspect and all of these sort of things. Okay, so we looked around it. You can see if we move in, you can see it's clearly the shaded area, and you can see if we look at this, remember the white is the highest snow cover, and you can see the snow cover here being on the southeasterly side, on the hill side of it. So it's got an aspect ratio to the east, southwest. It's got a elevation of a specific size. Let's quickly go the inspector. Let's click on this specific location there. You can see a snow cover quite a lot. Elevation, interestingly not that hot, but you can see a slope, fairly steep is. Aspect ratio 1:4. That's west southwesterly. Hillsides 128, so that's quite a lot of shade. And there's our terrain, basically just all in one. Okay, so we've done that. Now what we want to do is let's quickly just make it out, and remember there's all the layers. Okay, there's the terrain, the hillside layers, and again I can overlay it, etc., etc. Okay, so we've done all those things. I'm not going to repeat it again. They all what we spent the last 4-5 odd video tutorials was just on the terrain analysis for snow cover. So let's look at climate, specifically temperatures, rainfall, and the like. Okay, so what I want to do is, remember we worked with a climatic data product or data set called Terra Climate. So what I want to do is I want to go to Google Earth Engine, go to data set, and within data sets I'm gonna type in Terra Climate, and I should get to my Terra Climate, the one that we spent quite a bit of time with, which is this one, which is the monthly climate and climatic water balances. Okay, so that seems to be the one that I want to do. Remember 1958 to 2022. It's got a resolution of 4638. Let's just quickly have a look at my snow one. Data set, which is the Terra Snow. Let's quickly go there. Terra Snow cover data set. Let's quickly just confirm and refresh our minds, memory, what its spatial resolution is. Its spatial resolution is 500 meters. The Terra Climate one is 5,000 meters. So that may be a little bit, yeah, not ideal because this resolution is very, very low. So it covers, a pixel covers quite a large area. So yeah, but anyway, before we make any judgment, let's leave that for now. Okay, so let's go, and so let's go to its code. So let's copy and paste this one, and this is our standard code. So let's plug it into our project script. Then obviously we have to amend it a little bit, because what we want is the same time slots, so same time frame as our snow one, and our snow, remember, our snow one is for this particular period. So let's copy that period, and I'm gonna paste it into my time period filter date for my Terra Climate one. So I've done that. Okay, so now I've got the same time periods. Just make sure. Now what I want to do, okay, sorry, I need to clip it. So I'm just going to use the clip function. Let's see if that works. Otherwise, the map clip function, that can work. And remember, because we're using, in this case, we're using a sum, but I'm not going to use the sum. I'm just going to use our standard median. Yeah. So let's have a look there, because I want to reduce it because there may be more ones. So let's say median. Okay, our data set again. So we've already got a data set, so I'm going to change that to climate. So I need to make the necessary adjustments to my script, so I need to change it there. So I'm going to change that to that as well and say it's climate band. Okay, and then that's going to be, I'm going to say climate band visualization parameters. Now remember, we have to scale our variables because these are unscaled. Okay, so temperatures, chances is going to be minus 300. That's not going to be, so let's leave it for now unscaled, because we can do that a little bit later. Our map center we can delete, and then obviously our climate band is our variable name, so let's change it there. And our climate visualization parameters is that one there, so let's change it there. And I'm gonna just change the name to climate, because we're gonna use different bands, so I don't want to continuously change it. So in this case we're working at maximum temperatures. The TMMX, just confirm, if we go to our bands, TMMX is maximum temperature, and we have to scale it by 0.1. Okay, so remember, we have to scale it by 0. We're going to do that a little bit later, build in our scaling. But just for now, let's quickly just see what that looks. Remember, save first. So let's quickly save while it's got this little star sign. It's saving. Okay, star sign. Let's run it. See if there's any. Oops, we've got a problem. It doesn't want this clip function. Okay, so we're gonna go and do the map clipping tool. Okay, so let's do that one. Let's replace that, and let's run again. Perfect. Nothing red. Everything is fine. Save. Same time slot. Medium image. So I'm going to get a median maximum temperature image, which is reduced for this period. And we're going to display it. There we go. So let's unselect all these other ones. So we're only interested in the climate, which is maximum temperatures and snow cover. So why is there no maximum temperature? Okay. Anybody guess why there's nothing? Very straightforward. Nothing to it. That's where our landing page is important. Let's go and have a look. 2022. It only goes to 2022. And I've got 2023. So that means absolutely nothing. So, back to the drawing board. We need to find a date now where both have data in. So I think 2021 there was snow again. 2022 I don't think there was snow. So let's change it to 2021 and then see what that tells us. Okay, so let's click run now and see what happens. So I'm going to unselect the terrain features and I'm only going to display the snow and maximum temperatures. So let's have a look and see if there was snow, but you can see not much snow. You can see compared to previous years, that other period. Remember, there's that ridge, and you can see that ridge there. 2021, there was lots of snow there. 2023, 2021, there's very little snow. Okay, let's quickly. Let's have a look and see now if we go into. So this area here had snow quite a bit. See that side there. So let's have a look and see. You can see maximum temperatures is on the white side, so meaning cool. Remember, if we look at our, again, we can change these. It's got a lot of colors for this one. So if we go to inspector, we click on that one there. You can see the difference in spatial resolution. That's the first thing you notice, that climate is much bigger spatial resolution, and that's the size of the pixels. You can see that much bigger than the snow cover, which is not ideal. We wanted it to be the same because now that specific, let's say this, so this one here, this pixel here now covers, if we take it right, areas of high snowfall and low snowfall, and that's not ideal because now we cannot isolate temperatures. But anyways, let's go for it. So let's have a look and see. If I go to my inspector and I click on that specific pixel there, which indicates there's a lot of snow, let's have a look at climate. So that's, remember, I must divide by 10, or remember, because where is it, or multiply by 0.1. so in fact, where is it now? This value is 13 degrees. So that's the maximum temperature, 13 degrees. So let's go just to the green, that one there. Let's have a look and see there. Let's have a look at that maximum temperature, and you'll see the maximum temperature there is 17.9 degrees. So, but what's it, 4 degrees warmer. Let's go to that specific location there. Let's see what that maximum temperatures is. Remember, that's 18 degrees there. So you can see, well, there's a place here where there's a bit of snow cover here. Let's have a look and see there. Let's click on that there. Let's see what that maximum temperatures looks like. 12 degrees. So it looks like, you know, around 11, 12, 13 odd maximum temperatures there's snow. Let's look at this one, red here. See, that's the problem here. If I click on this red, it's give me the same climate because I am in the same climate pixel. So that's the big boo-boo from this, having that bigger spatial resolution. So I actually have to go somewhere, let's say there, that red there, which is still quite a high lot of, that's 11.6. less snow, but colder maximum temperatures. So that's interesting by itself. Now, let's look at minimum temperatures. So minimum temperatures is TMMN. So let's check that to TMMN. So let's do that. Okay, it's median. Run it again. So where I'm looking now at, and let's unselect the terrain specific and only focus on the, let's move into where the snow areas. Let's move this there. And that is the, remember, the darker the colors, well, we're going to have a look at it now. See what the colors look like. If you're not sure, then let's have a look and see. So where was it snowing? It was snowing there. Let's have a look and see what the minimum temperatures are. Minimum temperature 3 degrees. Remember, I must multiply by 0.1, divide by 10. 3 degrees. So 3 degrees. So that's very close to 0. Let's have a look. Go here. Okay, let's have a look and see what temperatures are there. 5 degrees. So about 3 degrees. Well, you understand what I'm getting to? Now we can play around. The problem is, I said, this the low spatial resolution of the Terra Climate one, but nonetheless, it does give some handy indication in terms of temperatures. We can also look at the rain. So let's quickly have a look and see what the rain numbers are. Let's have a look. What would be rain is participation. Wind speed we can look at, and participation is PR. Participation. Let's have a look and see what that number looks like. Because obviously, I would assume high rainfall. So let's quickly unselect my terrain specific ones. At least if we unselect it, the images loads much quicker. Okay, so there again, let's have a look and see. There's our snow area. Our climate one is there. Let's tick that one there. Let's look at participation. Participation 74 millimeters. So let's have a look in this side again with green. Let's take a look at in there and see what that number looks like. Oops, 97. What was that again? If in the high rainfall, let's have a look and see. 74. So interesting, less rain, colder, both daytime and nighttime. It's much colder than non-snowing areas. Let's have a look at another place. Let's have a look at this. See what this number, whether it's the same in terms of participation. Okay, so that's again a high snowfall area there. 62 millimeters. Let's go there, which is not that far away, and 64. So in both cases, let's look at this area there. In both cases, 70. Yeah. Let's look at this side, because normally the rain doesn't come from this side. 49. Okay. So again, it depends on the rainfall, the rain direction, because the rain comes from the northwestern side. From this side is typically the rain. So I would assume this area would have more rain than this area specifically because of the mountain. But does indicate that the higher you go up, most probably the steeper it is, most probably there's less accumulation of rain. That could potentially, the flatter, more accumulation of rain. That makes to me sense. The steeper the higher the slope, the steeper the slope, the less participation accumulation. That could be the reason why. Wind speed we can have a look at, but I think you guys get the idea. We can run for all of them, but I think wind speed, you can just remember always this scale, that you apply the scale, and we'll do that. I'll build in the scale for the next video, where we'll have the scale built in so that we get the actual numbers. You can just chop this up. Now again, let's go. This is PR participation. It's this bluish color. I'm not. It doesn't really talk to the visualization. It's difficult to overlay them. So let's quickly see if we can do anything. Remember, the higher, the darker the color scheme, the more the rain, and the lighter the fewer the rain or the less rain there is. Okay, so we have to go to, let's go to custom. So let's see there's a lot of colors there. I think we can change that quite a bit. Ugh. That doesn't make sense at all, because the red is to the maximum temperatures, I mean that's quite high rainfall, and this is quite low rainfall. Okay, so let's quickly, well, let's see 90%. If I go to 100%, let's go to the two extremes. Okay, so you see white is sort of in the middle, dark colors, blue colors is little rain, white is in the middle, dark colors is lots of rain. Let's close that. Well, let's make this decrease the transparency or increases transparency. So let's go to 30 and apply. I can't really see too much about that. That's no good. Let's go to 50 to apply. Okay, let's go in there. And in fact we have to, I think it must, let's do the opposite. Let's do climate. Let's make it full, and then okay, so that is our participation. Why is it must be part, oh goodness. Okay, so run again. I don't want it to show it in gray colors. Let's do that one, and we will go 100%. Let's see if we can do that. Okay, this is what we, okay, let's go now. Let's go 90% stretch. See what that looks like. Okay, so that gives you clear indication of low rainfall and medium rainfall and high rainfall. Okay, so let's go to our terrain, our snow cover, and let's do this one. We make let's say transparent. Let's see now if that works. Nope, maybe too much. Let's go. No, because it's not going to work, because that one is, so I need to make the climate one. It must be the, let's have a look and see, the climate one must be the one that we okay, so let's go increase. So that's our rain. You can see there the snow here, high rainfall areas. You can see there's not too lot of rainfall, but this is quite a high rainfall. Anyway, I think you get the idea. Same principle as the, let's save again, we haven't saved for a while. Same principle as the terrain analysis. Here we're applying climate analysis with our snow cover data product or snow cover image. And as I said, the idea is to get understanding of the characteristics of those locations that has snow cover in terms of its terrain and in terms of its climate. Okay, so that's, yeah, so let's we can have, at the end of the day, bring all these things together. Okay, now obviously we can export it similar to the previous one. We can export it. Let's go and we can export it. Let's create that export band, and we're gonna export it. We're gonna export its climate band, and in this case it would be in this case it would be participation, because we're working with participation. Interesting. Okay, let's do the sum of rain. Let's see what that looks like. Remember, we can reduce it by the sum, and our snow cover was reduced by a sum calculation. So let's quickly see what that looks like. And I'm gonna go into the climate one, and I'm gonna, remember, I think we had it 90% stretch. Let's have a look and see. 90% stretch. Well, it looks exactly the same, nothing different. Okay, so that doesn't really do much. terms of our vision. No, pretty much the same thing. Okay, anyway, I think you get the point, is that we can play around now with this. And obviously we can now export PR as well. There it sits in our task, unsubmitted task. We can obviously from there we can click run. There's everything, and we can run that. There it sits. It's now gonna export or download to my Google Drive, from where obviously I can now move it to my Earth Engine, my QGIS, and save. So now we've got now 3 data products in here. We've got the Terra Snow data product, which is the one that we're interested, and then we have let's call it explanatory data products, of which terrain is one through the digital elevation model, and then climate, maximum temperature, minimum temperature, rainfall is one via the Terra Climate data product. And we can display all of these visually in our layers section of Earth Engine, our layers, our map, and we can play around with the visualization parameters, etc., etc. And obviously always be interesting to use the inspector to get the actual underlying numbers, and we can export all these images. Okay, so that's, yeah, so that sort of enlighten us a little bit in terms of climatic characteristics of locations with snow cover. Okay. Yeah, interesting. And stay tuned. Please remember to like, subscribe, and to share. Remember, sharing is caring, so press that button, press it non-stop, and thanks for joining me on this journey, and I'll see you on the other side.